welcome. The topic we'll be discussing in this lecture is multiplexing. So, multiplexing is an important concept in wireless communication because here the wireless communication system uses shared medium. It means there is only one medium. Ideally speaking, only one person can use this medium at a time. So, the medium should be shared between multiple senders and receiver. So how the medium can be shared between different users with minimum or no interference. That's what we are going to discuss under this heading. So let us try to understand the concept of multiplexing using a normal example. So we can consider the highways. So if you see the highways, the highway contains different lanes. There will be a separate lane for as a pathway for somebody, for the people to walk, and there will be a separate lane for two wheelers. There will be separate lanes for cars. There will be separate lanes for trucks, like that. So that is also an example of multiplexing. Here the medium is highway, and the highway is shared among different users so that there will not be any interference. Here the interference is accident. And also different users use the highway at different time. It's not that everybody uses at the same time. Okay. So that is a real time example of multiplexing. So coming to wireless communication, here we have to share the wireless media, that is the air media, among different senders and receivers. So basically wireless communication supports four types of multiplexing. These are space division multiplexing, frequency division multiplexing, time division multiplexing, and code division multiplexing. So we'll be discussing all these four types of multiplexing, how it works, and what are the advantage and disadvantage of each of these techniques. Okay. So let us start with space division multiplexing. So you can see in this diagram. So basically this diagram shows six channels. These are the different channels currently we have: K1, K2, K3, K4, K5 and K6. So these are the space. This is the space is represented in a coordinated system. Okay. And the uh, and the space is represented with three dimensions like C, T and F, where C represents the code, T represents time, and F represents the frequency. Okay. So basically space division multiplexing means what? In the sense, see, we have only one channel, that is the air media. So the space division multiplexing says that let only one user use this channel. Let him use, that's it. And he will have certain range. He will have certain range. So within that range, it means that nobody else should use. Okay, nobody else should use. If somebody else want to use, then they have to go beyond that range and then they can use. Okay, so that it means it is multiplexed based on space. It is multiplexed based on space. Okay, so that means that space is for only for that particular sender. Say for example, we have a communication channel which is not there is a single communication channel, and we are not dividing it in terms of time or frequency or anything. Then say there is a radio channel. In that case, say if it is a radio channel, say this radio channel will be used in only one city. Say it is used in Bombay, and this radio channel will be used only in uh, this radio channel R2 will be used only in another city, maybe Calcutta, and this radio channel will be used only in another city, maybe Delhi. Okay, so for example, if the radio channel R2, they also want to use they also want to telecast or broadcast their content in in Bombay, then it is not possible, because R1 is already using that channel, because there is only one channel and you are not multiplexing, and you are not dividing that channel in any other form. It is given to R1, that's it. So it is here, the multiplexing is only with respect to space. Multiplexing is only with respect to space. So some other person or some other user cannot use this channel. Okay, so basically this is the idea of space division multiplexing. Okay, so so and these spaces also should be guarded, in the sense there should be some god space, there should be some empty space between two space. So basically, if you say this is space 1, say space 1 is using the channel. Okay, say this is the area of space 1, then after that space 2 is using the channel. Okay, because this is the range of space 1. Space 1 can go only up to this, so space 2 can take beyond this. So that doesn't mean that space 2 will start from here. No, there will be some gap between space 1 and space 2. So that gap is called as god space. So this god space is introduced to avoid interference. So similarly, there will be a gap, and then there will be space 3. Okay, so the entire communication channel will be used by space 1 here. The entire communication channel will be used by space 2 here, and by space 3 here. Okay, and this is the range of space 1, and this is the range of space 2, and this is the range of space 3. So there is no question of interference. So each space will use their will use the channel to the full extent. Okay, so in this diagram, if you see, there are 6 channels. So maybe you can allocate channel K1 to one space, and channel K2 to another space, and channel K3 to another space. So in this case, there are remaining 4 channels which is not allocated to any space. Then they should be they should be allocated to other other new 3 spaces. Okay. So so that is how space division multiplexing works. If you take old analog systems where each user was given a separate pair of copper wires for the local telephone exchange. Okay, so that is also an example of space division multiplexing in wired communication. So each telephone user were given a separate cable. So this cable is now space. Okay, this cable is the space, and everybody was given a separate cable. So that is an example of space division multiplexing. Fine. So next we will be discussing about frequency division multiplexing. The next thing we'll be discussing is frequency division multiplexing. In frequency division multiplexing, the entire communication channel will be subdivided into several frequencies, several non-overlapping frequency bands, and each channel will be allocated to each frequency. Okay, that is, every channel will have its own frequency. Here also we have God spaces to avoid interferences. Okay, so basically here actually it is, you can also call it as the God space is nothing but there will be some space between two frequencies. Okay, say for example, you may give some frequency, say let us assume say let us assume the frequency band 100 to 200. Okay, whether hertz or megahertz, whatever it may be, 100 to 200 was given to one channel. Let it be channel 1. Okay, let it be channel 1. Okay, then you cannot give channel 2 starting from 200 itself. Okay, 100 to 200 you are given to channel 1. Then you cannot start from 200 or 201 for channel 2. No, you have to give some God space. So then you can give maybe 205 to 305 for another channel, that is channel 2. Okay, okay, for channel 2, right? And you can give 310 to 410 for another channel. Okay, so there is a God space. Here we are maintaining a God space of 5 frequency. Okay, so here we are maintaining a God space of 5 frequency. So the God space is maintained basically to ensure that there are no interferences. Okay? So this is the purpose of God space, right? So if you take all radio stations, they basically work based on frequency division multiplexing. That is, each radio station will have its own frequency. Okay. So this concept is okay. This concept works fine with radio station, because radio stations works 24 hours a day, and and allocating a separate frequency for each station is fine. But that is not the case with mobile communication. In mobile communication, the communication the user normally talks for only few minutes. If a phone call comes, then he talks. Okay, so we cannot assign a separate frequency for a user, or for every sender, we cannot assign a separate frequency. In that case, if we allocate if we allocate uh, if we allocate a fixed frequency for every sender, then that becomes very inflexible system, and also it is a huge waste of the scarce resource frequency, and also it limits the number of senders, because the frequencies are limited, so the number of senders will also be limited. So this technique will not work with mobile communications. So uh, so the so here you can see the diagram of frequency division multiplexing. So each channel will have its own frequency. Here there are 6 channels. So channel one uses this frequency, works in this frequency. Channel 2 parallelly works in some other frequency. So the same channel is one. The communication channel is one, but each user will operate on a different frequency. So the channel is shared uh, with respect to frequency by multiplexing frequency. So the next type of multiplexing that we'll be discussing is uh, time division multiplexing. Okay. So in time division multiplexing, what happens in the sense, there is the entire channel, that is all frequencies will be used by a particular user in a given time. Okay. So maybe user one will be using the channel from time t0 to t5, and after that user 2 will be using. Okay, again user 2 will not start immediately at t5, maybe user 2 will start at t6. User 2 will be using the channel from t6 to t11, and user 3 will be using the channel from t12 to t17, like that. Okay, so here also there should be god spaces. So here the god spaces in terms of time, that is, between each users there should be some small time gap to avoid interferences. So that type of multiplexing is called as time division multiplexing. Okay. So the channel, every channel is given a whole bandwidth. Whole bandwidth means the entire frequency. So that is called as whole bandwidth. Every channel is given the whole bandwidth for a certain amount of time, not full time. So after this particular time, some other channel or some other user will use that particular channel. Okay, all senders uses the all the frequencies, that is the same frequency, because they all frequencies are merged. There is no, we are not differentiating with respect to frequencies, but they use the channel at different times. Okay, so that type of multiplexing is called as time division multiplexing. You can see this diagram. So here this diagram basically it shows 3 axes. The x-axis is frequency, y-axis is code, and this z-axis is time. Okay, so with respect to time, it is multiplexed. Different users use the channel at different times, right? So this kind of multiplexing is called as time division multiplexing. So time division multiplexing also should have God spaces. Here God spaces will be in term of time. So if we consider our original example, the highway example we discussed. So here time division multiplexing means different cars or different vehicles that were coming in the highway at a different point of time. But when different cars moves in the highway, there will be some space between two cars, right? It is not that two cars will, I mean, two cars will attach each other and they will move. No, there will be some space. So that space is called as God space. If there is no God space, then what will happen? Then there will be something called as co-channel interference. If there is no God spaces, that is, if two transmissions overlap. So in the highway, if two cars overlap, then that leads to an accident. Similarly, here, if two communications, if two signals overlap, then that will lead to co-channel interference. So it will lead to a problem called as co-channel interference. To avoid co-channel interference, there is a precise synchronization is required between senders and receivers. Actually, that is also one of the disadvantage of time division multiplexing, because all senders they need a precise clock. Whoever want to transmit, they need a precise, their clock should be synchronized so that they can ensure that there is no issue of co-channel interference. Okay. And the advantage of this system is it is a more flexible system. The advantage of time division multiplexing is it is more flexible because you can allot different amount of time for different users. Say if a user is heavily loaded, if a user is heavily loaded, then you can give him more time. He can use the channel for a long period of time. If a user is lightly loaded, then you can then the system can give him less time. That is, that particular user will be allowed to use the channel only for a few amount of time, right? So so and time division, so the next thing what we'll be discussing is time division and frequency division multiplexing can be combined. Okay. So this is an interesting concept. The time division and frequency division multiplexing can be combined. It means that is the channel ki can use a certain frequency band for a certain amount of time. Okay. Channel ki can use a certain frequency band for a certain amount of time, right? So that concept is called as combining time division multiplexing and uh, frequency division multiplexing. So in this case, what will be the God space? See, in space division multiplexing, space is the God space. In time division multiplexing, time is the God space. In frequency division multiplexing, frequency is the God space. Now we are combining time and frequency division multiplexing. So here the God space will be both time and the frequency. So the frequency also should be separated, and also two communication should be separated by both frequency and also by time. Okay. And actually this scheme is a more robust scheme in terms of selective interference. So if you take frequency division multiplexing, there is a high chance of selective interference, because the center is always going to work on the same frequency. So once the frequency is fixed, his interference is also almost fixed, because depending on the channel there will be an interference, because depending on the frequency there will be an interference. Okay. But here the center is operating at different frequency at a different time. Okay. So it is more robust when compared to frequency division multiplexing. Okay. And also this scheme provides some level of protection against tapping. That is, the combination of time division and frequency division multiplexing also provides some level of protection against tapping. What does it mean? Tapping means, say somebody yells, some unauthorized person is trying to listen to our communication. Okay. So that may happen if the unauthorized person know the frequency at which we are transmitting, then he can tap into that frequency and he can tamper the communication. Okay. But here the possibility of that is very less, because the sender is not operating at one frequency, sender is operating at a different frequency at a different point of time. Hence, tapping or tapping the data becomes difficult. So it provides some level of protection against that. So if you see GSM, Global System for Mobile Communication, and Bluetooth, so these are some of the technologies which uses this type of multiplexing. That is, they use a combination of time division and frequency division multiplexing. The disadvantage of this technique is, again, there should be a perfect coordination between sender and receiver. Two senders, if they if the two senders are working in the same frequency, then they may interfere. So the clock should be, the clock of the sender should be synchronized. So that is the disadvantage with this particular technique. And here is a pictorial representation of the combination of time division and frequency division multiplexing. So here you can see uh, again the x-axis is frequency, y-axis is code, and z-axis is time. So the user is using different frequency at different time. So this is the time. The sender is sending data with the different frequency at different time. So at this point of time, is using some frequency. At this point, some other frequency. At this point, some other frequency. And different users uses different frequency at different time. Okay, this may be belong to user one. He is using different frequency at different time. This may be belong to user two. Again, he is using different frequencies at different point of time. So this is more robust scheme, and also it does not waste the resource which is frequency, and it is used in modern communications like GSM and other technologies. Okay. So that's it about time division multiplexing and the combination of time division and frequency division multiplexing. So the next type of multiplexing that we'll be discussing is code division multiplexing. Okay. So code division multiplexing, or CDM, it's a very new concept. SDM and FDM are existing since olden days. So since the time of radio transmission, space division multiplexing, frequency division multiplexing, all these are there. But CDM, that is code division multiplexing, it is relatively a new concept. Initially, this concept, code division multiplexing, was used with military applications, but nowadays it is being used for normal civilian applications also. So here all channels use the same frequency at the same time. Okay, all channels use the same frequency at the same time, but they are multiplexed by code, but they are multiplexed by some special codes. Using these special codes, it is the information that is passed, it will be the information that is passed get multiplexed. Okay. So the separation is achieved by code, and the God space is also achieved through code. Here the God space is also, they are nothing but orthogonal code or the God spaces. So uh, so basically what it means in the sense, the see different senders will use the same channel, and all frequencies will be used at the same time, but whatever the sender sends, it will be encoded with the code. Whatever the sender sends, it will be encoded with a special code, and each sender will use a special code, and each sender will use a special code that is known only to that particular sender, and that is known only to that particular sender. And the receiver should use another code to decode that message, and the receiver should use another code to decode the message. The code used by the sender and the code used by the receiver should be orthogonal to each other. The code used by the sender and the code used by the receiver should be orthogonal to each other. So this is based on these principles, this particular multiplexing works. So all users share the same channel with the same frequency at the same time. but different users or different senders, they will encode their message with a different code. And for decoding, the receiver will be having his code, which is orthogonal to the sender's code. Using that particular code, the receiver will decode that message and he will understand. Okay. So this is also somewhat, it is something like a secure communication, because without knowing the code, the data is useless. Even if you can see the data, even if somebody else can see the data, as long as they don't know the code, as long as they don't know the secret code, they cannot decode the information. They cannot decode the information. So signal can be received, but it is useless without the secret code. Okay. So hence it is used in military applications. Hence it is used in military applications. So this type of communications can also be used in hostile environment. Hostile environment means that it is accept. This is you suspect that environment. You suspect that environment that you cannot communicate freely. So in that case, you can use code division multiplexing, because as a sender, you will be encoding the content with a code, and the receiver will have his own code, and with that content, with that code, he can decode and he can understand that particular message, whatever you want to communicate. Okay. So this is how actually code division multiplexing works. So this diagram shows the code division multiplexing pictorially. So there are different users who want to communicate through different channels like K1, K2, K3, K4, K5, and K6. But if you see the channel here, all the sender uses all frequencies at the same time. So different users can send data, but the information will be coded with the information will be encoded by using the secret code. The information will be encoded by using the each information will be encoded by using a separate secret code, which is known only to that specific sender. It is known only to the specific sender, and the receiver will be using an orthogonal code, and using that receiver will be using a code which is orthogonal to the sender's code, and using that code, the receiver will decrypt the message, and by that the receiver will understand what the sender wants to communicate. Okay. So so this is the overall working principle of code division multiplexing. The advantage of code division multiplexing is it provides protection against interference and tapping. Okay. Because here interference will happen only if two codes are similar. Here interference will happen only if two codes are similar. So the possibility of interference is very low. And tapping can be done only if I know an orthogonal code of the sender's code. Whatever the code with whatever the code which sender has encoded the data, I should have an orthogonal code for of that code. Then only uh, I can tap the data. So which is very difficult. So that is the advantage of this particular technique. And the disadvantage, so another advantage of this scheme is the code space is very huge when compared to the frequency space. The code space is very huge when compared to the frequency space. Even with frequency division multiplexing, the number of senders are limited because the number of frequencies that are available were limited. So only how much frequency bands are available, maximum we can allow only that many senders, right? But that is not the case with code space. The code space is very huge. So we can have as many users as possible. So that is also one of the advantage of code division multiplexing. Coming to the disadvantage, the main disadvantage of code division multiplexing is the it needs it expects the receiver to be highly complex. Okay. High complexity of receiver is required because receiver has to perform lot of tasks. So receiver should know the code, that is with which code it should decode the message. Okay. And the receiver should be able to separate noise from the data. It should be able to differentiate which is data and which is noise. It should apply the code, the orthogonal code of the sender's code correctly, and it should decode the particular information. Okay, so applying decoding correctly, so that is also one of the task of the receiver. And sender and receiver should be synchronized. Sender and the receiver should be precisely synchronized. Okay, and also the receiver should receive the signal with a good strength. If the strength of if the strength of the signal received by the receiver is not in a good strength, then the receiver may not be able to decode the message properly. So these are the disadvantage of this particular technique. So that's it about code division multiplexing. So, so this is about multiplexing. So we have discussed four different types of multiplexing: space division multiplexing, frequency division multiplexing, time division multiplexing, and code division multiplexing. With space division multiplexing, the entire channel is used in a limited space. Okay, so if the channel is used in one space, then within that range nobody can use it. Then out of that range, beyond that another space they can use. Okay, so but practically that is not possible. And then in frequency division multiplexing, the channel is divided into multiple frequencies, and each user is given a separate frequency. The typical example is radio, radio communication, radio broadcast. And then coming to time division multiplexing, the entire channel will be used by different users at different point of time. And then we have discussed a combination of time division multiplexing and frequency division multiplexing, which is where the user will use different frequencies at different point of time. So GSM and Bluetooth, these technologies uses a combination of time division and frequency division multiplexing. And then we have discussed about code division multiplexing, which is a relatively new technique where the channel is not multiplexed either with time or frequency. The entire channel will be used, but it is multiplexed based on special codes. That is, the sender will encode the data using that code, and the receiver will have a code to decode the data and to get the data, right? So that's it about multiplexing. Fine, let us stop here. Thank you.